Okay, so now we're going to talk about what the concept of pH is. And as a reminder, we said that pH drastically affects the function of enzymes. Okay, and let's just kind of follow this idea through, that if we drastically affect the function of enzymes, then that means that reactions, so if our, okay, let's put this another way. If our enzymes are functional, then reactions happen, and then life of the organism can continue. Well, let's follow that logic the other way. If enzymes can't function, then chemical reactions in the body don't happen, and then the organism can no longer live, or will get very sick first and then can no longer live. And so that's why when we're talking about pH, it's very important to keep pH in balance inside the body. Now, if you go to your notes packet, there's a place right here where you can fill in some information about pH. So let's do a little bit of that. So pH is a measure of the amount of hydrogen ions, and that's abbreviated as H with a little plus sign. Usually that plus sign is a superscript. So it's the amount of hydrogen ions in a solution, okay, in some sort of liquid. And this is actually measured. When they measure pH, they take a probe. So let's pretend for a minute that this is a probe, okay? And say this here has liquid in it. Well, I would take my probe, I would stick it down in the liquid, and it will measure how much how many hydrogen ions are in that liquid. And it does a mathematical conversion and comes out with a number. And that number is pH. So it's really just something that is measured. And pH is just a mathematical conversion that tells us how many hydrogen ions are there. It's a lot easier to say pH 7 than it is to say 1.86785 trillion hydrogen ions, okay, or whatever that number may be. So that's why they do it that way. Okay, so let's go back here, and so what can our pH numbers be? Well, they can be between 0 and 14, and this part is going to be important, okay? As pH increases, the amount of hydrogen ion decreases. Okay, so let's do this another way. As pH increases, hydrogen ion decreases. So they are always opposite. Okay, so that means as pH decreases, the amount of hydrogen ion increases. They're opposite. Okay, now let's add a few extra things down here. So if pH is 7, then it's called neutral. Okay. If pH is under 7, then it's called an acid. And if pH is above 7, then it's called a base. A lot of times you'll also see that written alkaline solution. Now, we need to add one more piece of information in here, and that's about this thing called hydroxide ions. Okay, so we said as pH increases, the amount of hydrogen ion decreases. Okay, well that means also amount of hydroxide ions, which those are abbreviated OH negative, that is going to increase. Okay, So hydrogen ions and hydroxide ions are also opposite. Okay, so let's ask ourselves here. So as pH decreases, goes down, the amount of hydrogen ion increases. So that also means that the amount of hydroxide ions decrease. Okay. So what does that mean down here with these numbers? So whenever something's neutral, then that's going to mean that the amount of H plus is equal to the amount of OH minus. Okay. With an acid, then that means that you have more hydrogen ions and fewer hydroxide ions. And for a base, then that means that you are going to have fewer hydrogen ions and more hydroxide ions. So neutral, hydrogen, hydroxide imbalance, and this is what happens with an acid or a base. Okay, so we've learned all these individual facts, but why does that matter? What's actually going on? How does that affect enzymes? Okay, so once again, let's think about this. This right here is going to represent my enzyme once again. Okay, so it turns out that normally there may be like one little, there may be a little bit of hydrogen stuck to that enzyme. And that affects the structure. And what's our theme that always applies related to structure? Structure equals function. Okay, so let's get outside of a normal pH. This would be normal pH in the blood. Okay, let's get too acidic. Too acidic means that now we've added a whole bunch of extra hydrogen ions. And it turns out these things are going to be sticky. And so they're going to come here. And what's happening to the shape of my enzyme? What's happening to the shape of my hand? It's changing. And remember, you change structure. What do you change? Function. And in most cases, this would mean that the enzyme can no longer work. Can this hand pick up reactants and make them into substrates? No, the shape is not right for that anymore. Okay? Alright, so now let's go back to normal. Okay, so this is how my hand has to be to function normally. But let's say now we're in a solution, say the blood is too basic, it's too alkaline. Well then, these hydrogen ions that it would normally grab onto float away. Okay? They go away. And now, is our structure the same? No, it's not. And so again, we've changed the structure, we've changed the function, and in most cases that's going to make this thing either not work or work too much. And so then that changes the chemical reactions happening inside your body, and you need those chemical reactions to live. Okay? So that is pH. Now there's a couple of activities here in your notes. Here are some different liquids, and your book can help you out, and you should arrange these from most acidic to neutral and then most basic. If a number is, the closer a number is to 7, the weaker the acid. So say if it's under 7, but it's really close to 7, it's going to be a weak acid. The further away from 7, the more acidic it would get. Okay, and the same for basic. Closer to 7, it's a weak base. Further away from 7, it's a very strong base. So arrange these in order. And then again, if you look on your homework lesson, this image is found in your book, and so here's some practice interpreting that, figuring out what that means, and arranging items. And the same here. Here's some items to arrange in order.